Good evening, one and all. Welcome to Math Classes by MSR. In this video, we will discuss about limits, full concept through examples. So, the basic definitions and all I am not going to tell you. Only the problem solving strategies we are going to discuss in this topic, in this video. So, first of all, basic idea. For the basic idea, I am going to define you what is limit of the function. Then after we will discuss only the problem solving strategies in this entire chapter. So, what is limit of the function? The basic definition of limit of the function is, see there, observing the tendency of the function f of x when x approaches to particular value from left and right. Did you understand? The observing the tendency of the function f of x when x approaches to particular value from left and right. So let us understand this definition through some examples. See, suppose a function, you consider one function f of x is x minus 2 by x minus 2 when x not equals to 2. By looking at the function, you can directly say that the value of f of x is 1 for every value of x other than 2. Yes or no? X minus 2 by x minus 2, how much? 1. Which is x not equals to 2. This is important. So in our domain, there is no 2. Did you understand? So f of x is equals to 1 when x not equals to 2. So in other ways, see what happens if x is equals to 2, tell me. F of 2 will be 2 minus 2 by 2 minus 2, right? That is nothing but 0 by 0. It is not defined. It is undefined. Right? It is undefined. So you can, for your understanding, it is undefined when x is equals to 2. Through the graph, let us understand this. Let us understand this through the graph. If you draw the graph, x-axis and y-axis, okay, suppose 0, 1, 2. See, if you see the graph of f of x, it is always parallel to x-axis, but at 2 there is no value only, right? At 2 no value only. So what we do is, just some adjustment. Yes, we got it. Now you see. So at 0, at x is equals to 2, the value of the function is not defined. The value of the function is not defined. Now you see the function as, if you see the values, what I said, the definition, the tendency of the function f of x when x approaches to particular value, when x approaches particular value. So that observing the tendency of the function f of x when x approaches particular value from left and right. So in the meantime, let us define what is x approaching particular value. So x approaching particular value, we represent it as x tends to a. Here a is the particular value. X is approaching a. What is the meaning of that word approaching is important. What is approaching a is, approaching a from left, approaching a from right. Approaching a from left, approaching a from right. Okay. So approaching a from left, we usually represent like x tends to a minus. Approaching a from right, we usually represent like x tends to a From right, x tends to a plus. From left, x tends to a minus. So what is the meaning of x is approaching a minus, and what is the meaning of x is approaching a plus? So x approaches to a from left, or x tends to a from left, both are same. X tends to a. So what is the meaning of that? What is the meaning of that? That is, x tends to a minus, meaning all the values of x which are smaller than a and very near to a. All the values of x which are smaller than a and very near to a. Here x is approaching to, suppose, meaning x is approaching to, meaning what is the meaning of x is approaching to? All the values of x which are smaller than 2 and very near to 2. Smaller than 2 and very near to 2 means 1.99, 1.999, 1.9999, 1.999, so on. All these are the values very near to 2 and smaller than 2. That is called, so those set of values. Okay, x tends to a minus, meaning all the values of x which are smaller than a and very near to a. Now x tends to a plus. X tends to a plus. What is the meaning of x tends to a plus? Same. All the values of x which are greater than a but very near to a. All the values of x which are greater than a but very near to a. If a is 2 here, x is tends to 2 plus. What is the meaning? What is the meaning? All the values of x which are greater than 2 but very near to 2. Suppose the values 2.01, 2.001, 2.0001, 2.0001, or 2 very near to 2. All the set of values we consider in x tends to a plus. X tends to a plus. So now we understood what is, see now, what is the meaning of x tends to a? All the values of x which are very near to a, which are greater than 2, which greater than a and less than a. That means the value of x tends to a, meaning the meaning of x tends to a is all the values of x which are very near to a, which are maybe greater than a or less than a. That is x approaching a meaning. So now let us understand the definition. If x approaches to a particular value from left and right, just now we discussed that. What is the meaning of x approaching? So when x is approaching a particular value from left and right. Okay, now x is approaching from left. So if you take the values from left, 2.01, 2.001, 2.001, so on the values, this f of x is, for this also the value is 1, even to this one, even to this one, all the values it is 1 only. So it is approaching 1 only. Yes or no? And from right side, from right side, from right side also. So 2.01, 2.001, 2.001, so on, all these values which are approaching 2 from right, there also the value is approaching which value? At x is equals to, there is no value only, it is not defined, but in the neighborhood of 2, in the neighborhood of 2, the value of fx is approaching some particular value, that is 1 here, that is 1 here, means x is approaching a, but f of x is approaching some particular value L. That means limit x tends to a. In short, how do you define this? The other way of writing this statement is limit x tends to a. When x is approaches to a particular value, what is the meaning of this? X approaches to a means x approaches to a particular value from left and right. Then what is the tendency of the function? Function's tendency is approaching to some particular value, right? Some L, say suppose. But in this problem, when x is approaching to, f of x is approaching 1. So this is called limit of the function. This is called limit of the function. So observing the tendency of a function when x approaches to particular value from left and right is called limit of the function. Is called limit of the function. Let us try to understand in detail with one more example. One more example. Let us write one more example. One more example, that is fx is equals to x square when x not equals to 2 equals to 1 when x is equals to 2. Let us try to understand this also. So it is very much clearly defined what is f of x when x not equal to 2, and what is f of x when x is equals to 2. Very clearly defined this. So let us try to understand this through the graph. So draw the graph. Oh, excellent. So though it is not looking like symmetrical about y-axis, let us assume that it is symmetrical. Okay, shape of the graph. Now let us see. So 0, 1. At 2, there is a gap. There must be a gap, right? Because at 2, the function value is not exactly the value of the given function. That is the much better to understand. So 1, 2, 3, 4. So no worries. But at x is equals to 2, what is the value of the function? It is 1. So this is the graph of the given function. Now try to understand. As per the definition, when x approaches to 2, what happens is, tell me. X approaches 2 means we need to check two ways, from right and from left also. When x approaching to 2 minus, what happens? 2 minus, and x approaching 2 minus. So suppose x value is 1.99. What about x square value? I already calculated. Okay, that is 3.9601. If x is 1.999, then what is x square is 3.996001. When x is approaching, when x value is 9999, x square value is 3.99600, so on. Suppose this is from left. What happens when x is approaching 2 from right? 2 plus values. That is, x is equals to 2.01, then x square will be 4.0401. Okay, if x is equals to 2.001, what is x square is 4.004001. If x approaches 2.0001, then x square approaches 4.000040001. Now if you observe both the values, if x is 1.99, which is less than 2, 1.99, the x square value approaching 3.96. 3.9 means which is very near to 4. Again, x is equals to 1.999 when is approaching 2. When is approaching 2, 1.99 is less than 1.999, less than 1.999. Then the value is 3.96 less than 0. 3.996 less than 3.999, so on. So the values are approaching which value? 4. Right? All these values are approaching which value? 4. From right side you see. From right side you see. At 2.01, the value of x square is 4.0401. 2.001, the value of x square is 4.0040. So it is reducing the value from 0.04 to 4.004. Next, x is equals, still we are reducing the value of x, means as it is coming near to 2, the value of f of x is coming near to which value? 4. Right? Right? So that means as limit extends to 2, the given function f of x is approaching to which value? 4. This is called limit of the function. This is called limit of the function. So limit of the function is not that when x is equals to what is the function value? X is equals to 3, what is the value of the function? That is not the limit of the function. Limit of the function, as clearly stated here, observing the tendency of the function when x approaches to particular value from left and right. That is called limit of the function. Now let us discuss what is left tendency and what is right tendency. Left tendency, see here, what is the limit of the function we discussed? Observing the tendency of the function f of x when x approaches to a particular value from left and right. From left and from right. From left, the function approaches some certain value, right? That value we call it as left hand limit or left tendency. As well as what is right tendency or right hand limit? As we discussed, the function f of x tends to some certain value from right. From right. Such value, that value we call it as right tendency or right hand limit. Very, very important this is. So as we discussed earlier functions, both the functions what we discussed, y is equals to f of x square and y is equals to x form, both what we discussed. So in continuation, let us take one example now. Suppose take the example. Suppose if we see one function, I'm drawing the graph like this. This is the graph. This value is some say take some. So graph of this function is suppose the function is f of x. Now if you see, it's a left tendency as the value of x approaching to, suppose this is from 2, some 3. This is some 4. So now you see the value of x is approaching 2 from left. The function value is approaching 3, right? The value of the function is approaching 3. It tends to 3. Whereas the value is approaching from right. Value is approaching from right of 2. The function value is approaching 4. That means its left hand limit is 3, whereas right hand limit is 4. Left hand limit is 3, right hand limit is 4. Now tell me, in this case, the tendency of the function f of x differs from left to right. In this case, we should say that the limit of this particular function does not exist. Always LHL should be equals to RHL. Then only we say that functions limit exists. Left hand limit should be equal to right hand limit. The previous two examples what we discussed there, both left and right hand limits exist and both are equal. Okay, so here suppose for example, if we take a function, simple example like this, f of x equal to some x squared. F of x is equals to x squared. Okay, so now if you see this graph, x squared plus 2 we take. F of x is equals to x squared plus 2, suppose this is 2. Now if you see this graph, anyway, suppose at point 3, the value is approaching is approaching 9. 9 plus 2, 11. This is 11, say suppose. Now what we say that from right and from left, okay, from left and from right, the x value is approaching 3, the value of the function approaching 11, both from left and right. So here the limit exists because whose left hand limit is equals to right hand limit. But there exist some functions where left and right hand limits does not exist. For example, if we take an integral part of x, f of x is equals to integral part of x. Suppose f of x is equals to what? Integral part of x. So whether the function is exists at any integral value or not, we should check it. We know that if you want to check the function exists at 2 or not, at 2. Now tell me, what is the functional value at x f of f2 is equals to 2, right? And 2.1, where it goes? Tell me. Integral part of our greatest integer function. 2.1, 2 to 3, the value goes to 3. Right? Sir, no. Sorry. So the value goes to 2. In between 2 and 3, the function value goes to 2. But if it is between 1 and 2, the function value will be 1. Between 3 and 4, function value is 3. We know that, the graph of the integral part of x. Now if you observe, any value more than 2 means when x is approaching 2 from right, the value of the function is 2. The value of the function is 2. Means right hand limit is 2. Now from left if it is approaching 2, any value is approaching from left, that is LHL, is approaching what? 1 only, no? Yes or no? It is 1. So right hand limit is not equals to left hand limit. Hence, at x is equals to 2, f of x, limit of f of x does not exist. So this is about left hand, right hand limits. So let us discuss some problems based on left hand and right hand limits. Very, very important concept. If you are able to solve problems based on this concept, you can able to solve remaining problems also. So very, very important. So here limit extends to a minus is left hand limit what we discussed. And so while solving problems, let us remember this limit h here. H is very, very, very smallest real number, a small positive real number. H tends to 0. Then f of a minus h. This is the notation we use for left hand limit. Limit x tends to 0, f of a plus h. This notation we use for right hand limit. So while you're solving the problems, we use this. Okay, to find left hand limit and right hand limit. Okay, so let us continue solving problems based on this. So in the next video, we will discuss about the remaining concepts as well as problems based on the completed concept just now. What we completed, left hand limit and right hand limit. Based on that, we will discuss some problems, very important models. And moreover, the remaining concepts and the problems based on that also we are going to discuss in the coming videos. Thank you very much. We'll meet again. Bye.